This video introduces a single-shot detector for object detection. Single-shot detector uses a deep convolutional neural network to detect objects in images by discretizing the output space of bounding boxes into a set of default boxes over different aspect ratios and scales per feature map location. Compared to the previous method, SSD doesn't require a region proposal net to generate regions of interest. SSD generates scores for the presence of each object category in each default box and regresses the bounding box to better match the ground truth box of actual object. Finally, non-maximum suppression is used to select the better match bounding box for each actual object. SSD architecture and pipeline are shown here. Give a feature map in a convolution layer with S by S grid. The model scans the feature map using a 3x3 filter to generate 4 anchor boxes at each step. Each bounding box has 4 parameters, so that the total parameters are S by S by 4 by classes plus 4. 3x3 filters are used to convolute the feature maps from convolution layer 5 to convolution layer 11. And the result concatenate as the input to the detection layer, as shown here. Filter parameters are used to predict the classes growth and offset of boxes relative to the ground truth. The total number of boxes per class is 8,732 boxes, as marked here. Indicator XIJP represents matching between the default bounding box I and the ground truth box J of category P. Sum of XIJP equal larger than 1 means that match is reached between bounding box and the ground truth. The total loss L is a weighted sum of localization loss and confidence loss, as shown here, where N is the total number of boxes and alpha is a balance factor. Confidence loss and localization loss take the similar formulation with those used in faster RCNA. 3x3 filters convolute the feature maps to generate centers of default bounding boxes. The offsets of a bounding box relative to the ground truth box are defined as here. X and Y are calculated from the nonlinear activation value, where M is index of the positive bounding box. X and Y are features at a feature map location, and DIC X, CY are center of the ground truth box I. Suppose that key feature maps are used for object classification and detection. The scale of the default bounding boxes for feature map K is computed by using this formulation, where S minimum is on the lowest layer and X maximum on the highest layer. Aspect ratio AR of bounding box is taken to be 1:3, half and 1/3. Width and height are computed from SK and AR. We use K to calculate W and H, and we use a convolution to calculate XI and XY. The bounding box information together with the ground truth boxes as input to the detection layer. Detection layer uses this information to produces the positive bounding boxes and associated growth as input to the classifier and regressor. For more details, please check with these references. Thank you. Bye.